We are now going to do a two-way ANOVA. Imagine we have a data set in which observations on vigilance were made both in the morning and in the evening, and this was repeated on another day. One day was warm, the subsequent day was cold. Now obviously we could either do two t-tests, one for AM versus PM and the other for warm versus cold. But if we do that, then we're going to have to apply some sort of Bayesian correction, and we'll take an easier approach, and that is simply to do a two-way analysis of variance. So here I have the data organized. There are 13 observations for AM on the warm day, 13 for PM on the warm day, and then also 13 for AM on the cold, and 13 for PM on the cold day. So I have a term up here that says group. My two columns are time, and my two groups, warm versus cold, are labeled down here. So again, we're going to go over to the Data Analysis tab. When this little dialog box opens up, we're going to select ANOVA two-factor with replication, because we do replicate the observations, and click OK. Our input range is going to be this entire group here, which includes these labels up here at the top. I have 13 rows for each group, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 13 up here and 13 down here. I'm going to use an alpha value of 0.05, and then my output range, I'm going to put that right here. So then I just have to click OK, and there are the results. Let me make this first column a little bit bigger so that we can see what's going on. These are just summary statistics, AM versus PM here, warm day versus cold day. And these are the total values down here. What we care about is this table down here, what's referred to as the Anova Table. Here we have the sample is for warm versus cold columns, that's AM versus PM, and here's something called an interaction term. So is there a relationship between AM and PM on a cold day versus a warm day? And what we notice, or what we want to pay attention to here, are the p-values. So what this p-value, this first one, tells us is there is a difference between the samples. So in other words, the vigilance on a warm day is not the same as vigilance on a cold day. So we're going to reject the null hypothesis that vigilance is equal on warm days and cold days. It is not. The next question is it greater or less on a warm day versus a cold day? Well, to make that determination, you would go up here and look at these values. Okay, so average vigilance on a warm day is 8.07, average vigilance on a cold day is 5.19. So vigilance on the warm day in this sample would appear to be greater. The next thing we want to look at here is the columns, which is AM versus PM. And you'll notice here that the p-value is not less than 0.05. In fact, it's 0.75. So there is no difference in vigilance in the morning versus the evening in this particular sample. And similarly, if you look at the interaction term here, you'll notice that the p-value is less than 0.05. In other words, there is an interaction between time of day and temperature, and you would have to make a little graph to figure out what the nature of that interaction term is. But overall, the model is significant, and we do now know that the vigilance on a warm day is different from the vigilance on a cold day. And up here we determined that vigilance on the cold day, the average vigilance on a cold day was actually less than the average vigilance on a warm day. Very good.